Can you see my shared screen?
Yes, sir.
Yes, sir.
Okay, so I'll quickly recap what we did last time and then move on to the next topic. So we covered the central limit theorem last time, which essentially said that if you have a sample from a population which has a certain mean and standard deviation, then for large values of n, the sum of those random variables will approximately have a normal distribution. That is the main idea of the central limit theorem, and it is very powerful because we are not assuming any distribution on these random variables. So these xi could themselves have a normal distribution. They could have a binomial distribution. They could have an exponential, Poisson, geometric, hypergeometric. Uh, they could have any distribution whatsoever. Uh, but their sum, as long as it is sufficiently large, in fact, n equal to 30 is on the higher side. Sometimes even for n equal to 5 or n equal to 10 also, you will start seeing behavior similar to normal distribution. So we saw an example of tossing dice. If you toss one dice, then you expect all the outcomes to be equally likely. However, if you toss two dice, then 7 has the highest likelihood. Then you have 6 and 8, and the lowest likelihood is that of getting 2 and 12. Similarly, if you throw three dice, then I think uh, highest likelihood will be that of 9. Uh, I think this could be 9 or 10. I'm not sure, but yeah, one of those numbers. Lowest likelihood is that of 3 or 18. Okay, so you start seeing the curvature, and when you increase the number of dice, then then it will go, then it will become more and more closer to normal. Then we looked at an example of, let's say, an insurance company which has 10,000 automobile policy holders. So 10,000 is definitely much more than 30. So it will definitely have a normal distribution, the sum of these claims. Then we said that expected claim for each person is this, expected standard deviation is this. What is the probability that the total yearly claim is above a certain number? So you're talking about total yearly claim. So the central limit theorem comes into play. Central limit theorem is about sum of random variables. So when we are talking about total yearly claim, then we are talking about the sum of random variables. So random variables x1 to xn, and we talk about their sum, that will behave like a normal distribution. Okay, and then we said that we can subtract mu and divide by sigma by root n to make it standard normal. Then we looked at another example for that. Let's skip this, and then one more example we looked at. Yeah, so this is where we stopped. So, so before moving on to the next topic, I want to just do a quick case study about how to uh, choose random samples. Okay, so let's say there's a company uh, which wants employees to carpool. It wants to reduce the carbon footprint. It wants many people to come in the same car together. Maybe another motivation could be that the number of parking spaces in the organization are low, and it wants to ensure that more and more people come together as much as possible. So what it says is that if average number of employees per car is less than 3, then it will take some actions. So it wants the average number to be more than 3. So they do a survey, and then they say that if the average number of employees per car is less than 3, then they will consider starting corporate carpool service, so that more and more people come through the organization's carpool, and then they will increase parking fees for people who don't carpool. So people who are coming alone in their car, they will start increasing their parking fees. So in order to conduct this survey, they choose 100 workers at random, and then they ask how many other people were there with you, or rather they ask total number of people in the car in which you came today. And then it took a total of all that. So let's say Anuj said 3 people, Bhavna said 2 people, Jill said 4 people, Kavan said 3 people. So it took a total of all this, total of all the responses, divided it by 100, and they got 3.4. That was the answer. And then they said that, okay, so this means that people are carpooling sufficiently, hence we don't need to take the actions of starting corporate carpool service or increasing parking fees. So the question is, this analysis is wrong. And the question is, why is it wrong? Am I audible?
Yes, sir.
Okay, thank you. So now you are means what? I was not audible earlier, Jill?
For 2 minutes, you are not. I
No.
heard this 3.41. After then, for a while, 1 minute, you are not speaking, I think so.
Yes, I was not speaking because I was waiting for you guys to answer. I asked a question. What is wrong with this analysis? What is the mistake here? Company wants to find out how many people per car are there on an average. If the number of people per car is less than 3, they'll start corporate carpooling. They'll increase parking fees for people who don't carpool. The intention is to encourage people to carpool. They choose 100 workers at random. They ask how many people were there with you in the car today when you arrived. They took total of all the responses divided by 100. They got 3.4. So Jill said 3 people were there in my car. including me. Bhavna said 2 people, Kavan said 5, Ketan said 1. They totaled all that, divided by 100, got 3.4. What I am saying is that the company made a mistake in doing what they did. Why? Yeah.
अगर कार में एक ही पर्सन है तो उसके लिए तो मतलब इंडिविजुअल्स के लिए अलग अलग फीस चार्ज कर सकते हैं.
I didn't understand, Jill. Can you speak louder?
We can charge individually. If there is only one person in car, then the charges are different. And if there are three persons in car, the charges will be different. And
What
if
are you
there are
talking
five,
about? What is the question and what are you saying? The question is not about how much to charge the people. What I am saying is that this analysis is wrong.
Sir, these samples are not independent.
They are independent. You have chosen 100 workers at random. You have 1,000 employees, maybe 10,000 employees in the whole company. You are choosing 100 people at random. There is no mistake there. It's not a trick question. The question is this number 3.4 the answer to what we are looking? What is the answer that we are looking? Average number of employees per car. This is what we want to find out. Is it equal to 3.4? I am claiming it is not 3.4. Why?
Because it is given that it is less than 3.
Where is it given it's less than 3? तुम लोग सो रहे हो? Where is it given it's less than 3? I've clearly written if the number of people in a car is less than 3, then the company will take certain actions. And in order to determine whether it's more than 3 or less than 3, it is trying to do a survey. I'm saying there is a mistake in the survey. What is the mistake? And you need to understand this part because statistics is a lot about how to choose the random sample. And people don't get this. They can do the calculation, addition, subtraction, deletion, division. That is easy. But you need to have clarity how to choose a random sample. So what is the mistake here in choosing the random sample? That is the question.
Sir, should the number of people per car not depend on the size of the car?
That is irrelevant right now. Most cars can accommodate 4 people. It's not nothing to do with the size of the car.
Sir, but we can charge more if in a car which is having more seats, less people are sitting.
But Tarang, you are talking about the wrong problem. I'm not talking about charging here. That is not the problem. We're not discussing how much to fine people. Do you get that?
Yes, sir. Yes, sir.
So this is the second part. This will come later. That increase parking fees for people who don't carpool. That is secondary. These steps will be taken if the average found is less than 3. The company did a survey and they found the average to be 3.4. So they did not take any action. But my point is that the way they did the survey was wrong. And the question is, what was wrong in that? That is the question. There's nothing to do with this. Forget about this. This is what is called as misleading information. This is not useful for you to solve the problem. So ignore this, ignore this, ignore this. In real life, when you're trying to solve a problem, there is a lot of extra information which is given. And you need to be able to weed out things which are not important or which are not relevant. It's important but not relevant to the problem right now. So nobody will tell you X is this, Y is this, compute this. You have to figure out what is important and what is not important. So in this example, this has no meaning. The question is this. You have to find out average number of employees per car. That is the problem. How do you solve this problem? The way the company solved this problem is by choosing 100 workers at random. They asked each one कि तुम्हारी गाड़ी में कितने थे, उनका total किया, divided by 100, they got 3.4. And I am saying this is wrong. The question is, why is this wrong? So the mistake is not in the random part. They choose people at random. That is not the problem. Problem is this method is wrong. Question is, why is it wrong? No. We are not trying to find the population mean here. We just say that on a particular day, let's say today, let me find out how many people on an average have come in a car. Let's talk about today. So let me give you a hint. Let's say there are 4 cars that come that day. Let's just take a small toy example. Okay. Let's say 4 cars are in the parking lot. In car 1, 4 people came. Car 2, 4 people came. Car 3, 2 people came. Car 4, 1 person came. How many people are there on an average per car? You need
2.7 car.
Yes. How did you get that?
Average
How did you get that?
4 plus 4 plus 2 plus 1 by 4.
Yes. So you got 11 by 4, which is 2.75.
Hmm.
Is the company doing this? What are they doing and what will be the average that they will get? कंपनी ने क्या किया है? If you follow this method, then what average do you get? You don't get 2.75. What do you get? Are you able to see the problem or not? Pujan Patel, if my screen is not visible, then you need to disconnect and connect again. There is nothing wrong with my internet. I'm clear about it. I have Geo. You guys are doing ICT, right? You can't apply a simple algorithm? Really? What are you doing in DA? You're wasting your fees, guys. This is the algorithm. I'm asking you to apply this algorithm to the data given on the next page and tell me the average. Yeah. Anyone in the car? That is. Yes. Their response will be the same. Yes, exactly. So if you were to follow the algorithm used by the company, how many employees are there in this page? There are a total of 11 people who came by car. So if you were to ask person 1, how many people were in your car, he will say 4. Person 2 will say 4. Person 3 will say 4. Person 4 will say 4. These 4 people came in car 1. Then you ask people in car 2, they will all say 4. Then 2 people came in car 3. They will say we came with 2 people. And then one person came in car 11. He will say there's one person in my car. What is the total of all these? This is what the company did. It gave a questionnaire to 100 people and it summed up their responses and divided by the number of responses. So in this case, there are 11 people. So these 4 people said 4 each. These 4 people said 4 each. These 2 people said 2 each, and this person said 1. So what is the total of all these responses? What is the total? Yeah. And how many people are there? And what is 37 by 11?
3.36.
3.36, 3.36. What class are you in? Yeah, after decimal, you never say it like 36, 46, 55, 100. It's 3.36. It's more than 3. So do you see the huge disparity in the two? This is 2.75 and this is 3.36. And this is wrong. This is completely wrong. And this is what the company did. The goal was to find average number of people per car. This was the goal. They didn't find that. They took 100 people at random. They found out how many people were in the car along with them. They totaled all that and divided by 100. Now the problem is that cars with more people, those people have more likelihood of getting selected. And they will obviously say a higher number. This person has less likelihood of getting selected because this is only one. So this will be skewed in favor of people who have come in bigger cars or with more people. So the correct way to do this analysis is go to the parking lot, choose 100 cars at random, find out how many people came in each car, total that and divide by 100. The correct way of doing it, go to the parking lot, choose 100 cars at random, find out how many people came in each car, sum of the responses divided by 100. This will give you the average number of people per car. The problem here was it is the wrong population. Some of you pointed out that it may not be random, it is random. But the population is wrong. You're not supposed to sample this population. You're not supposed to sample the population of people. You're supposed to sample the population of cars. That is a mistake, and it's a big mistake. And it's an easy mistake to make. It is an easy mistake to make. It is easy to think that, oh, let me survey 100 people at random and find out how many people were in the car along with them, and then I'll total that and I'll figure it out. But it doesn't work. Okay, so by the way, since we're talking on this topic, let us also talk about how to choose a random sample. Let's talk about that a little bit before we start with this whole section. So let's say, continuing with this, how to choose a random sample on a computer. Let's say you're writing a code, okay? Let's say you have a population of, let's say 100, let's say 1,000 items. You want to choose 3 at random. How do you do that? In fact, to begin with, what do we mean by a random sample in this case? Yeah, Vandan? Your population of 1,000, you want to choose 3 at random. What do we mean by choosing 3 at random? When do we call a sample to be a random sample? Guys, if you're not willing to participate, you should leave the meeting.
Sir, can I try to answer this question?
Who is this?
Sir, Tarang.
Yeah, bolo.
Sir, I think that a random sample means we cannot predict in advance which sample will be chosen.
That is one way to say it. That is one way to say it. But more importantly, probability of choosing any sample is the same. So if you have 1,000 items, how many ways can you choose a sample of size 3? Yeah. So there are 1,000, choose 3 subsets of size 3. And sample is random. If the probability of choosing or selecting any of these is the same. So if suppose you were to number your elements as x1, x2, x1000, then you could be choosing x1, x2, x500. You could be choosing x9, x15, x999. You could be choosing x1, x25, x600, and so on. There are how many of these? There are 1,000 C3 such samples, 1,000 C3 such possible subsets. So the probability of choosing this or this or this or this or this or this, it is the same. Then we say that the sample is random. How will you do it on a computer? So that is the question. How to choose a random sample on a computer? Let's say your data is stored in an array and you have an array of size 1,000. You're going to code. Consider an array with 1,000 entries. And the problem is choose a random sample of, let's say, 20. How will you do that? Let's say you're coding in C or Python or Java or Pascal using some programming language. How will you choose a random sample of size 20? What will be your algo? What will be your code? How will you write it? Is the question statement clear? In Python, there might actually be a library or a function to do it directly. I'm not sure. But if it is not there, how will you randomly choose 20? Yeah. This is just the definition of what we are discussing. A sample of size n selected from a population of size capital N is said to be a random sample if it is selected in such a manner that the sample chosen is equally likely to be any of the subsets of size n. So there are 1000 choose 20 subsets. Will you list all of them and then choose one of them? Everybody is thinking that somebody else should respond. Sending in breakout rooms, think about this. It's a very simple problem, but you guys are not participating. I don't know what to do with you. So I'm sending you to a breakout room. Just think about this for 5 minutes and then come back and then see. Yeah. So the question was, consider an array with 1000 items. How do you choose a random sample of 20? Vandan, how will we do it? Yeah. Yeah, good. So that will work. So to make it simple, assume that you have access to a random number generator. Assume that the programming language in which you are working already has a random number generator, which will give you a random real number between 0 and 1, let's say. Then how will you use that? Or even to make it more simpler, let's say you can choose a random number between 1 to 1000. You have some routine which can choose one random number between 1 to 1000. How will you modify that routine to choose a random sample of 20?
Hello, sir.
Yeah, who's this?
Jill, sir.
Yeah, Jill.
So, sir, first we create an array of 20,
Okay.
and from that 1000 entry, first we will copy first 20 of that entries into the new array.
So you're saying you make a new array of size 20 and you
Uh,
copy paste the first 20 entries from the 1000 array to this new array.
yes, and from 21 and 21 to 1000 entry, we will generate a random number from our current item in the 20 array of 20.
I didn't get this part.
We will generate a random number from 0 to x, where x is index of current item in our array of 20.
Okay, let's say we have this is an array of 1000.
Hmm.
Then you create a new array of size 20.
Hmm. First, we will copy.
You copy these. So let's say this was 5, 7, 2, 9, 11. Let's assume these are also numbers. Okay, now what?
Now, from the 20, which the below array, we will select a number. Uh, uh, if our current position is, for an example, 4,
You start from first. Now, what is the step one? You made this new array. Now, what is the next step?
we will generate a random number from 0 to x, where x is the index of current item in the array of 20.
What is current item?
Uh,
You tell
and if
first
we are
step. Are you talking about this number? Let's say you start from the beginning. Are you talking about this?
any of this,
So are you saying you generate a random number between 1 to 20?
yes,
Okay, so let's say I generate 3.
now if the three, um, uh, no sir, I think I was mistaken.
Okay, I got that. So one simple way to do this could be uh, to let's say you choose. So you have an array of 1,000 entries. Let's say n entries. Okay, and then you choose a random number between 1 and n. This is the first step. You have the array from 1 to n. Then the step 1 is choose a random number between 1 and n. So let's say, so you basically have to make 20 choices. You have to make small n number of choices. So the idea is you choose a number, then you choose another number, then you choose another number. But the catch is, if you've chosen a number, you don't want to choose it again. That is the main catch. So when you are selecting uh, 20 numbers at random over here, you don't want to select the same number twice. Then it will not be a random sample. So what you do is choose a random number between 1 and n. So let's say you selected this xj. Now you have to figure out a way to mark xj so that you don't choose xj again. And that can be done in several ways. One way could just be to delete it from the array. But if you delete it from the array, then you have to shift all of these 1 unit to the left. And that is expensive. If it's a long array and you delete one number, then you have to shift everything else. So this comes here, this comes here, this comes here, this comes here. That is expensive. Don't want to do that. Another way to do it is you just mark it and then you generate another random number. If it is the same as this, then you choose another random number. And you keep doing it until you get a different random number. Most likely it will work. Another way could be to swap this with the last entry and then choose a random number between 1 and n minus 1. So what you could do is swap xj and xn. So now the array looks like x1, x2, x3, xn, xj. So now xj was the first number that was chosen. So now in the next step, you choose a random number between 1 and n minus 1. So now you're going from here till here. So let's say you choose some xk. So then you swap xk and x n minus 1. So you have x1, x2, x3, xn, xn minus 1, xk, and xj. So now these two are the chosen ones. Earlier xj was the chosen one. Now xk and xj are the chosen one. And you keep repeating this. So now you'll choose another number and then you'll swap this with you'll choose another number, then you'll swap it with the third last item and so on. And you will choose a random number between 1 and n minus 2 and so on. So at the end, the last 20 numbers will be your random sample. This is one way to do it. As I said, there are other ways to do it. You can delete this as soon as you choose it, but then that will require shifting. You could delete this and keep this cell empty. That is another option. If you get the same random number again, then you can calculate another random number and so on. So there are various ways to do it. But whatever way you choose, you need to ensure that it is actually giving you a random sample. That is the critical part. Any questions about this?
No, sir.
Okay. So the next topic that we want to study, this is about this sampling proportions from a finite population. So we'll be asking questions like what proportion of a population is in favor of a tax hike? What proportion of the population favors a particular candidate? What proportion of the population believes in getting vaccination? So we're talking about proportion. So it could be mentioned as percentage or as a fraction. So let's say you have a population of size n in which certain characteristic is present in certain elements. For example, being left-handed, having blonde hair, favoring a particular political candidate. Okay, so we're talking about certain characteristic which is either present or absent. It's basically binary. Either it's there or it's not there. We're talking about those scenarios. So somebody being left-handed, somebody having a particular physical appearance, somebody having a particular uh, preference for a brand of milk or a biscuit or something. Okay. So now let's say that we denote the proportion of the population that has this characteristic. What does it mean? It means that n times p elements have it and n into 1 minus p do not have it. So let's say there are 900 students in a school. 60 are left-handed, and p is equal to 60 by 90, 1 by 15, and 840 are not left-handed. The fraction of people, the proportion of people who have this particular characteristic is 1 by 15, and 14 by 15 is the fraction of people who don't have this characteristic. Okay. So now talk about random sampling. We are assuming that the problem is solved. So suppose that a random sample of size n has been chosen from a population of size capital N. So assume that the random sampling has been done. It is over. You had a population of size capital N. From that, you have chosen a random sample of size small n. Okay. Now you choose an indicator random variable xi and you define xi to be equal to 1 if the ith member has the characteristic and 0 if it does not. So let's say if we talk about the school example, school has 900 students. Let's say you choose a random sample of 20 students. So you have x1, x2, x3 up to x20. x1 will be 1 if the first student is left-handed, otherwise 0. x2 will be 1 if the second student is left-handed, otherwise 0. Similarly, x20 will be 1 if the 20th student is left-handed, otherwise it will be 0. So this xi is, so this I is going from 1 to n, the lowercase n, where n is the sample size. So this n is the sample size. So you've chosen, let's say, 20 students in the sample. For each of those 20 students, xi is either 1 or 0. So this is an indicator random variable. We are looking at examples wherein either that thing is there or not there. So either somebody is left-handed or not left-handed. Either somebody has hair of a certain color or not there. Preference for a particular politician or not there. So either something is present or not present. We are looking at those examples. So the value of xi is either 1 or 0. It is 1 if the member has the characteristic and 0 if the member does not have that particular characteristic that we are looking for. Okay. So now in terms of xi, we define x so what is x? So the total number of members in the sample who have this characteristic. So suppose again we go back to this example of being left-handed. So you chose x1, x2 up to x20. Let's say x1 was 1 because first person was left-handed, x2 was 0, x3 was 1, then 0, 0, 0, and then 1. So let's say 3 people out of 20 were left-handed. So sum of these xi is 3 is equal to x is equal to total number of students who are left-handed from the sample, in the sample. Okay. So in the whole school, there are 900 students, out of which 60 are left-handed. You choose a random sample of 20 students. X1 is 1. So each xi is 1 if that particular student is left-handed from those 20. You sum all these 3, you get 3. So this is the total number of students who are left-handed in the sample. So that is what you are getting in this x. So this x is x1 plus x2 plus xn. Total number of members in the sample, not in the whole population. This is total number of members in the sample who have this particular characteristic. And then similarly, you can define x bar. X bar is x by n, which is summation I equal to 1 to n of xi whole divided by n. So this is the proportion of members in the sample who have this characteristic. Yeah. So x bar is x by n. So again, if we go back to this example, then what is x bar here? X bar is 3 by 20. Because out of 20, 3 people had this characteristic of being left-handed. X1, X3, and X20. These 3 were 1, others were 0. So X was 3. So X bar is X by N. N in this example is 20. So this is X by N. N is 20, X is 3. So X bar is 3 by 20. Now the question is, what is this? What is this quantity? P of xi equal to 1. What is this probability?
Half.
P of xi equal to 1 is half. Why is it half? Why is it half? So something can be 1 or 0. Does it mean that the probability of both the events is the same?
No, sir. It will be 1 by 50.
It will be?
By 50.
Say it louder.
1 by 15.
1 by 50.
15.
15. Yes. So it will be this P, which is 1 by 15 in this example. If you choose a person at random, the probability of that person being left-handed is 1 by 15, which is basically P in this particular example. And probability of xi equal to 0 is 14 by 15 in this example, which is 1 minus P. Now the question is, are x1, x2, xn independent? That is the question. Okay, so we can't complete this discussion in the remaining time. You think about this. Are they independent or not? Okay, we'll discuss this in the next lecture. Any other doubt about what we did today?
No, sir.
Okay, so I think our next lecture should be not
On Friday.
Yeah, it is on Friday, but are we meeting in a classroom or online? That is not clear to me.
Online. Online.
Are you sure about that? Because I've read so many.
Yes.
I've
I
not
think
clarity.
till 16 or 18 April, it is on hybrid mode.
Yeah, but there was another email, right? What does hybrid mean, by the way? Hybrid means what does hybrid mean? Does it mean that we continue like right now? Because right now it's not hybrid. Right now it's fully online. What I saw in one of the emails, by the way, there are too many emails. One email said from 1st April we will have hybrid, and from 18 we will have offline. So I'm not sure. But anyway, if you figure it out, you please let me know what we need to do for Friday.
Hello, sir.
Yeah.
Some professors were saying that next week it will be Offline means in classroom.
Who said that?
Yes, Vasavada sir said that next Monday will be on offline.
In the classroom? Have you been
Yes.
in classrooms?
Yes, sir, I guess so.
What is your classroom, Vivek?
We don't know, sir.
Okay, you just said you know.
Means it will be on in classroom, but we never go there, so we don't know.
But which classroom? तुझे मालूम होना चाहिए ना कहाँ पे आ रहे हो? By the way, how many
Sir,
of you
we
have,
are,
how many
sir,
of you have
we are
been
on
on
campus.
campus?
Many of us are on campus.
Like many means what? You have a batch of I think almost
Yeah,
400.
yes, sir.
380?
No, sir. All are on campus. All are on. The persons who have taken both doses, they all are on campus.
But is it the whole batch or is it half of the batch? Do you have
No,
any
sir.
idea?
Wall batch.
It is the whole batch.
Everybody got both the doses.
Yeah, almost.
मीन्स कुछ
Means
होंगे पर वो शायद बहुत कम है.
the administration has invited all of us who has taken double doses, the whole batch.
Yeah, I know that part. I know that the administration has invited, but I want to know how many if we have accepted that invitation and actually shifted.
That is, we also do.
We also don't know. And there was some rumor I read, or rather some other faculty shared with me that students are going to boycott lectures from Monday because of some issues. Are you guys aware of it?
No, sir.
Okay. There was some notice put up in faculty blogs. Somebody said it is from SBG. So I don't know what's happening. Anyways, I if it is online from Friday, then I think sorry, if it is hybrid from Friday, then I will see you in the classroom. I think timetable should say which classroom we need to go, and I think hybrid means you're still allowed to attend. So right now you guys are in the hostel. That's what you're saying. Are you in the hostel or are you still at home?
Most of us are in hostel.
So you're connected from hostel right now, Vinay.
Yes, sir.
I see. Okay. So I think hybrid means you have a choice. Okay, we'll see. I'm assuming some email will come and we will know by Friday where to meet. Bye, guys.